Welcome back to question for November 2022, grade 12 maths paper 2. It was an analytical geometry question where we're dealing with circles. Now let's go ahead and look at this one, guys. We've got two big circles here and also a small one. We can already notice that the small one is at the origin, which is going to be very, very critical. I'm assuming that when we answer most of these questions. Okay, let's go ahead, read our question. It says here that M, which is -3:4, is the center of the large circle. All right, great stuff. So this is the center of the large circle, and a point on the small circle having a center OO. We already noticed that there is a center OO there, and therefore from n -11 h to p is a tangent drawn to touch the large circle at t. Okay, it's touching the large circle here. Okay, with tn parallel to the y-axis. Okay, we see that tn is parallel to the y-axis. Okay, great stuff. I always do like this. Also can see that they are parallel. I don't like showing parallel with an arrow because really when we are dealing with analytical geometry, when we say the gradients are parallel, we always show them like that. Okay, then it makes life easier for me to remember that one. Okay, and then mn is a tangent to the small circle. Where is mn? Mn is here. Is a tangent to the small circle. Okay, thank you very much. Let's just extend this tangent here so that we can see it clearly. There you go. I'm extending this line here, which is mn, which is a tangent to the small circle with MOS a diameter. Oh, MOS is a diameter. Okay, therefore meaning that this is the radius. This is the radius. It's got equal. Okay, great stuff. So now we have managed to read that. Let's move on to 4.1. If you didn't read the question properly, guys, please pause this video or go through it again, gather as much information as you can so that it will be easy for you to follow as we answer the question moving right along. All right, so now 4.1, determine the equation of the small circle. You have to remember that the small circle is at the origin, so therefore 4.1, the equation of the circle with the center at origin is given by x squared plus y squared is equals to r squared. Okay, is equal to r squared. R equals to r squared. Okay, so now we need to find what is r. We already have the radius there, so we are gonna substitute our x that we are getting here from the m. There is gonna be -3, because these coordinates you are getting them from the m because the center is here. It's 0 0 here at the center, so you are going there, which gives you this radius here. So plus 4 squared is equals to r squared. Great stuff. So therefore r squared is equal to, just gonna give us how much? Let's see, r squared is going to give us 25. Therefore we leave it like that because now we are looking for r squared, we're not looking for r. So therefore our equation of the small circle is going to be given by x squared plus y squared is equals to 25, which is this one, is the equation of a small circle. Okay, great stuff, guys. I hope you guys are following. So let's move on to 4.2. Determine the equation of the circle centered at M in the form of. Okay, so now we have to determine the one for the bigger circle. Okay, and then we just need to calculate the radius. Okay, how are we gonna calculate the radius of this one? Okay, great stuff. So now to calculate the radius, we need to find the equation. We need to find this line here. Okay, rather I promise you guys I'll use a different color for different questions. Let me come here because now I don't want you to get confused. Okay, so now we need to calculate this radius here, which is the radius of the bigger circle. Okay, so now we need to find this distance here, which gives us the radius of the bigger circle. So now let's come here, 4.2. Before we can proceed, because we need to find this r. Already we've got the center. We know that a is the coordinate at the center, and then a and b is, this one is the x coordinate. We know that our center is given by this, which is happen to be at m. Okay, So this one we already know, we are comfortable with this, but now we don't know the distance, which is the radius, which is r. So r is unknown, so we need to find r. So now if you have a look at this, the coordinates at t, I think this is a very interesting question. This coordinates here at t, look at n is directly sitting there, sharing the x value. N and t, they're sharing the x value. So therefore you can come here and say, okay, well, I can see that we already have minus 11 here. But if you have a look at here, t is also sharing, okay, rather they are sharing, is also sharing the y value with m. Do you agree, guys? Have a look at it. Here is our y here. Here is our y here. Y and m, they are sharing the same value. So you've got a 4 there. Okay, so easy and straightforward. You didn't have to bother yourself. You just have to look at analytically how is this diagram looking. So I know guys, please go, let's go through it one more time together. Okay, tn, they are directly on top of t, is directly above rather n, okay, or below if you want to call it below. So now these two, they are sharing the x value. They are sitting on the same x value, which is here. Can you see that? So it's easy to say, okay, if this is negative 11, so at t I must have negative 11 as well. So even here, this m, they are sharing the same y value, which is here. Is the same y value that goes all the way to t. Okay, so we can say, okay, if m has got a 4 y value here, which is 4, therefore t should have also a y value of 4. All right, so therefore now what do we have? We have got m here at -3:4, then we have got t here at -11:4. Great stuff. So now we can go ahead, use our distance formula to find mt, which is also there. Okay, our distance formula here, I'm not gonna, should I write it all the way? Okay, let me write it rather. We're gonna use x at t minus x at m all close squared plus y at t minus y at m all close bracket squared. Now we can substitute our values here, guys. Please make sure that you are following. If you're not following, please let me know. -11 minus 3. Okay, these are our x values plus our y values. They are given by negative, no, rather not negative, is given by 4 minus 4 all squared. Okay, therefore mt, which is our radius for the bigger circle, it is going to be given by, if we punch this into our calculator, let me see how much I'm getting. I am therefore getting 8 units. It's our radius, so it's going to give us 8 units there, which is our radius. So therefore for the bigger circle, the equation of the bigger circle, it is therefore going to be given by, because this is our general equation, I'm just putting it here, guys, so that when I substitute, it's easy for you guys to follow. R squared, okay, it is going to be given by, this is the center, remember the center is m, so this is our m here, it's -3:4. So now it's going to be given by x minus into -3, which is minus into -3. Please guys, don't forget these minuses, and maybe you want to ignore them, please don't do that. You are gonna get it wrong. Squared is equal to r. Remember, r is 8, but here we're looking for r squared, so we are going to substitute our 8 there, then we're going to give it a squared rather. Okay, so now let's simplify further. Minus is going to give us plus all squared here, plus y minus 4 squared, and therefore 8 squared is going to be given by 64. Okay, and now this gives you the equation of a bigger circle. Okay, this is the equation of a big circle. All right, and that's how you deal with the questions like these ones. Let's move right along to question 4.3. Okay, moving right along, 4.3. 4.3 says here, determine the equation of nm. Okay, equation of nm. So here is our n here, so here is our m there. They want us to find this equation here. Okay, all right, so now what we can do, remember this is the center is given by the coordinates o o. Okay, so what we can do, we can find the gradient of MO, and we know that MO is perpendicular to, okay, we can find the gradient of MO, which is perpendicular to the gradient of MN. Okay, and the product of these gradients, because they are perpendicular, should give us -1. Okay, all right, therefore let's start with this one here. Gradient of MO, because we already know the coordinates here, is going to be given by y at m minus y at o all over x all over x at m minus x at o. Okay, so therefore guys, with this one said, I know you're thinking, okay, what if I use y2 minus y1 all over x2? I've explained this several times, guys. When doing mathematics, I said it doesn't matter, as do what you're comfortable with. I have changed to do it with the letters because most of my learners prefer doing that, because they said they get confused when they have to do with y1 and x1 and x2, because really there's no 2 and the 1 here, it's only variables. Okay, so let's come here and said, okay, y at m is going to be given by 4 minus 0 all over x at m minus 3, or is equal to 0. Therefore the gradient of MO is going to be given by 4 over -3. Okay, so we know that they are perpendicular to each other. To get -1, therefore the gradient of MN, if you substitute this gradient into this formula here, you should be able to get this one. I'm going to leave it for you guys to do. You are going to get 3 over 4, so that their product can give you -1. All right, great stuff. So now with that in mind, which means now we have the gradient of this line here, so we only need 1 point to substitute and get the equation. So we go to my favorite equation on analytical geometry. It's going to be given by y minus the gradient of the line that we are looking for, x at m minus x at m minus x. Is it? No, x at m is on the other side, x here and then x at m here. Okay, thank you very much guys for assisting me there. Therefore you're gonna come here, said y, you are substituting the coordinates of m. Okay, you're looking for the y at m is 4, is equal to our gradient 4 over 3 x minus into minus 3, then close bracket. Then we can deal with the algebra thereof. I'm just gonna continue up here guys. Okay, you are going to have y minus 4 is equals to 4 over 3x plus 3, close bracket. Therefore you are looking for the y now is going to be 3 over 4x plus 3 times 3 is 9 over 4, therefore plus 4 here, that this 4 moved to that side here. Therefore our y for mn is going to be given by 4 over 3x, and therefore to deal with that fraction is going to give us 25 divided by 4. Okay, great stuff. And that's how you deal with a question like that one. All right, so moving right along, let's calculate the length at 4.4. Says we need to calculate the length of SN. Okay, let's come right here and deal with the length of SN. Length of SN, which happens to be this length here. All right, but we don't know the coordinate of S, and we also don't know the y coordinate here at n, but we know the equation at that line. Okay, so now we can easily find the y value there. Okay, let's come here and say 4.4. We are saying y mn is given by 3 over 4 x sorry, is given by 3 over 4x, which is our gradient. I don't know why I'm putting a bracket there, but never mind. Okay, x plus 25 over 4. Okay, so we are saying we have got n here. It's sitting on this line. The x coordinate is 11. So what is the y coordinate there? Okay, let's look for it. Now we're going to substitute x here and look for the y coordinate. So the y coordinate, which happens to be p, I'm just going to write it here as p, is going to be given by equal to 3 over 4 x is at negative 11 plus 25 divided by 4. Okay, so therefore our p is going to be equal to how much? Put this in our calculator punch. Therefore we are getting negative 2. So therefore we know what is p now. So therefore n is going to be given by negative 11 is negative 2 there. Okay, all right, but you like say, how are you going to get the length here? Because this is what you are looking for. You're looking for this distance here. Okay, but I said, okay, we don't know these coordinates here at s. We don't know them. Okay, but this O here can act as a midpoint. This is our radius. This is our radius. So if this is the midpoint here, you have this point here. So therefore you can find this coordinates here. Let me say that again. You have got a line. I think I've shown this before. You have got a line. There it is. The midpoint is 0.0 is to 0. This is our midpoint, which happens to be the center of the small circle. And then you have got a point here, which is point M. Let me say this is the center. Let me put say C here. Okay, coordinates. Okay, negative 3 is to 4. I don't know why it doesn't want me to erase this one here, but anyway, it's fine. Then we have got S there, which is the, you don't know the coordinates of this S here. You don't know the coordinates of this S here. Okay, we don't know the coordinates here of the S here. Oh goodness. Okay, it's not erasing, but anyway, it's fine. We are looking for the coordinates of S here. So now if we have the midpoint, we can use the midpoint formula using the midpoint formula in reverse. Okay, let's go ahead, use the midpoint formula in reverse and try to find this equation rather. Okay, we're gonna come here and say, okay, the x coordinate at midpoint is going to be given by the x coordinate at M plus the x coordinate at S all over 2. This one is 0, is going to be equals to, at M is negative 3 plus the coordinate at S all over 2. Okay, and then therefore we're going to do cross multiplying here, leaving us with the coordinates of S to be 2 times 0 is going to be 0, and then negative 3 will move to the other side, then it's going to be 3. Same thing should apply here with our y value. Our y value at M is going to be equals to y at M, which is this one here. This one didn't want me to erase here. I should have been calling it C, but I hope you guys can follow, plus y at S all over 2. So therefore we are going to have 0 there. Therefore our y there is 4, is going to be y S all over 2. Cross multiply, therefore our y at S is going to be negative 4. Okay, so therefore our x value, our S value is equals to 3 is to, okay, no, sorry, is it 3? Yeah, 3 positive 3 is to negative 4. Okay, and that's how you deal with this one. And therefore to calculate the length of this, you are gonna come here and say, okay, S n, since we have got all the coordinates, there is our first coordinates here and there is our second coordinates there. You can therefore use the distance formula, which I'm not going to write here, guys, because I don't have space here. I'm just going to substitute directly to say the x1 value here is negative 11 minus 3 squared into the distance formula. Okay, and then minus 2, minus into minus is going to give me plus. Therefore I'm moving a little bit quick now. Okay, and then 2 there. Then we have to punch this in our calculator, which therefore end up giving me 10 square root of 2. units. Okay, got a little bit messy there, but I hope you guys fully understand what just happened there. If you don't, please let me know on the comment section, and make sure that you are subscribed, because you don't want to be left out when we do a solution to your comment. All right, moving right along to 4.5, which is the last question on the series of these questions of question 4s from November 2022 up until 2020. Great stuff. Okay, moving right along, let's move on to 4.5. 4.5 said, if another circle with a center B, negative, let's look at this, negative 2 and 3y. Where are we? What's somewhere here? Okay, negative 2 is to 5, and a radius k touches the circle at point M. Okay, touches the circle at point M. So it means this B, it's somewhere here. Let me try to put it somewhere where it's a bit realistic. Negative 2x somewhere there, and 5 somewhere here. Negative 2 is to 5. Okay, determine the k value and correct to 2 to 1 decimal place. Okay, so basically they're just asking us to calculate this value here. Hope you guys can follow. So now how do they want us to calculate r, the radius? Okay, so now the radius of this circle will just simply be this one here. This should be the radius of this circle. So what we can do now, we can come here and have a look at this one and then calculate the distance between a BM. Okay, 4.5. We need to calculate the distance between BM to give us that radius that we are looking for. All right. Okay, so let's come here and say MB into the distance formula. Oh guys, okay, I don't like putting the distance formula. You guys already know it. You can check it on your formula sheet. All right, trying to be as polite as possible, guys, but I mean, can't keep writing the distance formula. Minus into minus 3. It's already in our head, guys. We should know it by now. Okay, and then 5 minus 4 all squared. And if we simplify this further, we punch this directly into our calculator because we don't want to waste time. We're in an exam. It's going to give us 2 units. Okay, so that's the radius actually of the circle that was formed. So this is equal to the radius. Okay, so therefore, having that in mind, now they want us to calculate the k value. Okay, so now to calculate the k value, let's come here and have a look. To calculate the k value, what are we looking for? Okay, let's have a look at here. Okay, we have got this here, which is our B. Okay, so now they want us to calculate the k value. So the k value would be k value going that side and then k value going this side. Okay, guys. All right. Question, guys, requires some serious attention and some serious working out. So to make this video short, I agree with what you guys are saying. We are gonna make a separate video for this question alone, which is 4.5 of November 2020, to clearly explain what needs to be done here. So please make sure that you are subscribed to this channel so that you see when we post this video. So please go ahead and press this button here that is at the bottom there and subscribe to our channel, and then you won't miss out when we upload this question, because seriously, this question, make sure that it needs some serious attention. If I were to do it here, you guys, I know you guys wouldn't really fully understand it, but please make sure that you stay tuned and you are subscribed so that when we post this video, you are definitely going to see it. Thank you very much for tuning in. I am Gaston Mapala. See you on the next upload, where we'll be doing question 5s of November 2022 up until 2020.